off with a really simple topic known as the electromagnetic spectrum. And to start this topic, we have to talk about the principal particle, which are photons. Photons make up the electromagnetic spectrum, and they make up this electromagnetic spectrum by these randomized motions in different axes, in both the x, y, and the z axes. This movement of these particles result in the energy of said photons, and this energy can be quantified in this equation. So E equals Planck's constant, which is denoted by H, and V, which is the frequency in hertz. This gives us an energy of the photon, and it kind of gives us a relationship between energy and said frequency. If the Planck's constant is constant, which given by the name it is, we can increase the frequency, resulting in an increase in energy. So when we talk about photons and how they make up the electromagnetic waves, we talk about the speed of these photons in the electromagnetic waves in relation to how their wavelength progresses and how their frequency progresses. So, if we look at the relationship between wavelength and frequency, we get this equation. I have a question for you guys. If we decrease the wavelength of a said wave, what do you think will happen to the frequency?
It increases.
Perfect! You guys, we are going to jump right into our first assignment. That first assignment is going to be to have you guys look at different real-life scenarios and products that show you these different waves along the spectrum. So have fun! So I know these humans have these things called radio waves, which go from 1 meter to 10,000 kilometers, and I know that they have these boxes on wheels that they like to sit in, and inside these boxes they have these smaller boxes that can detect all the radio waves coming from every single direction, and that way they can talk to each other and listen to music and stuff. So I have these other waves called microwaves, which go from 1 millimeter to 1 meter, and I know that these humans have these other boxes that they like to put their food in, and their food gets hit by all these microwaves and it heats up, and that's how they cook, and these boxes are just called microwaves. Humans on their boxes. And then they also have infrared waves, which go from 700 nanometers to 1 millimeter, and these waves allow humans to figure out how hot things are. So I know that on Earth, which is where all these humans live, there's a pandemic going on, which means that everyone's just getting really, really sick for no reason, and so they get like really hot when they're sick, and the government gave these humans other boxes, whether or not a person is like too hot before going into their workplace to prevent people from getting more sick. And then there's also visible waves, which go from 390 nanometers to 750 nanometers, and these are the kind of waves that the human eye can detect. So that's the way they see like blue and red and green and all these like interesting colors.
First on our list are ultraviolet rays. They tend to be between the 10 and 400 nanometer range. A good example are tanning beds. Some people use them to get more tanner when they don't naturally are able to get tanned outside. Some doctors use them to treat psoriasis. Next on the list are X-rays. Let's say that you're on a line scooter, you hit a curb, and then you hurt yourself. A doctor may use an X-ray to confirm a fracture. And lastly, we have gamma rays. Gamma rays are less than 0.01 nanometers. New advances in medicine are using gamma rays to help treat brain cancers and brain tumors. It's called a gamma blade, and basically just concentrates gamma rays into a small portion, and it inhibits further cell growth by destroying the genetic material within the